Hey there, Math Wonders. In this lesson, you will learn how to write an equation in function notation and evaluate a function for given input values. This will be page 5 of your table of contents. Your vital vocabulary. So, in this situation, we're going to determine a relationship between the x and y values, and then we're going to write an equation for that relationship. So in this situation, we want to find out what is happening to x, these x values, to get y. Y is a result of x in some fashion. So I'm going to suggest that we list the possible relationships between the first x or y values. So just looking at 5 and 1, how can we go from 5 to 1? Well, we can take away 4 from 5, that'll give us 1, or we could take 1/5 of 5, and that too will give us 1. Secondly, we're going to determine if one relationship works for the remaining values. So I'm going to plug in the remaining values and see if taking away 4 from each x value gives me the subsequent y values, and I think it's obvious that it does not. But if I do take 1/5 of the x values, it does give me the y values. Consequently, the value of y is 1/5, or 1/5 of x. So our equation would be y equals 1/5 x, or y equals x divided by 5. Taking a look at a set of ordered pairs, looking at the x values, what happens to x to get y in each of these scenarios? Put in the table, we might be able to see a little bit better. The possible relationships, I could be multiplying x by 3 to get y, or I could be adding 2 to x to get y. So let's test those two possibilities. If I multiply x by 3 each time, it does give me the subsequent y values, whereas if I add 2 each time, it does not. So the value of y is 3 times x. Write an equation, the value of y is 3 times x, or y equals 3x. Now the equation in the previous examples describes a function because for each x value, or input, there was exactly and only one y value. The input of a function is the independent variable. The output of a function is the dependent variable. The value of the dependent variable depends on or is a function of the value of the independent variable. We're going to focus on using this function language and function notation throughout this lesson. So in this scenario, let's identify the independent and dependent variables. We've got a painter must measure a room before deciding how much paint to buy. So the two variables would be, measuring the room, the size of the room, or the measurement of the room, and how much paint is needed. So which depends on which? The amount of paint, of course, depends on the measurement of the room. The bigger the room, the more paint. So the dependent variable is the amount of paint. The independent variable is the measurement of the room. In this scenario, the height of a candle decreases d centimeters for every hour it burns. So the height of a candle depends on the number of hours it burns. The longer it burns, the shorter the candle. Consequently, the dependent variable is the height of the candle, and the independent variable is time. Oftentimes, when time is one of the variables, it will be the independent variable. Time is dependent upon no thing. A veterinarian must weigh an animal before determining the amount of medication. Well, the amount of medicine or medication depends on the weight of the animal. You wouldn't give a horse the same thing you would get a schnauzer, would you? So the dependent variable is the amount of medicine, whereas the independent variable is the weight of the animal. Little helpful hint. There's several different ways to describe the variables of a function. Independent variables can be referred to as the x values, the domain, the input, and the x, whereas the dependent variables can be referred to as y values, range, output, and f of x. Okay, you try this now. Identify the independent and dependent variables. A company charges $10 per hour to rent a jackhammer. Pause the video now. Okay, welcome back. Hopefully you identified that the cost to rent the jackhammer depends on the length of the time it is rented. The longer you rent it, the more it costs. Consequently, the dependent variable is the cost and the independent variable is time. Try this one. Apples cost 99 cents per pound. Pause. Welcome back. The cost of the apples depends on the number of pounds bought, so the dependent variable is the cost and the independent variable is the pounds. So an algebraic expression that defines a function is a function rule. Suppose Tasha earns $5 for each hour she babysits. Then 5 times x is a function rule that models her earnings. If x is the independent variable and y is the dependent variable, then function notation for y is f parentheses x close parentheses, which is read f of x, where f names the function. When an equation in 2 variables describes a function, you can use function notation to write it. So once again, this focus of using this type of notation, f parentheses x, which is read f of x, is going to be a focus here. So the independent variable, or rather the dependent variable, is a function of the independent variable. Another way to say that is y is a function of x, or y equals f of x, or y equals f of x. All these essentially are saying the same thing. So in this situation, we're going to identify the independent and dependent variables, and then we're going to write an equation in function notation for the scenario. So math tutor charges $35 per hour, not bad. And if the fee a math tutor charges depends upon the number of hours. The more hours, the more the fee. Consequently, the dependent variable is the fee, and the independent variable is the number of hours. So if I let h represent the number of hours of tutoring, then the function for the amount of math tutor charges is f of h equals $35. The function of h equals $35. Essentially, we're replacing the y, what would have been a y, or the dependent variable, with the function notation f of h. In this situation, we have a fitness center that charges $100 initiation fee plus $40 per month. The total cost depends on the number of months, plus $100. The dependent variable is the total cost. The independent variable is the number of months. So if I let m represent the number of months, then the function for the amount of the fitness center charges is f of m equals 40m plus 100. You try. Stephen buys lettuce that costs $1.69 per pound. Please pause. Alright, so hopefully you recognize that the total, or rather the total cost, depends on how many pounds of lettuce Stephen buys, of course. So the dependent variable is the total cost, and the independent variable is the number of pounds of lettuce. If we let x represent the number of pounds Stephen buys, then the function for the total cost of the lettuce is f of x is, or equals, $1.69 x, or 169x. Again, it doesn't matter what variable you choose. The x is not significant specifically, so that's not relevant. Now we can think of a function as an input-output machine, also called a function machine. For Tasha's earnings, f of x equals 5x. If you input a value of x, the output is 5x. If I put in x in the function machine, then out comes 5x. If I put a 2 into the function machine, out comes a 10. If I put a 6 into the function machine, out comes a 30. So inside the function machine is applying the function rule, and the output is coming out. So we're going to evaluate, thinking in lines of this function machines, we're going to evaluate the function for the given input values. So if my function x exists and it is 3x plus 2, we're going to input the value when x is 7 and then when x is negative 4. So I'm going to evaluate this function when x is 7 Notice how I changed my notation from f of x to f of 7. So if f of x equals 3x plus 2, then f of 7 would equal 3 times 7 plus 2, which is 23. Likewise over here, we're going to change f of x to f of negative 4 equals 3 times negative 4 plus 2, and then the value of that function when x is negative 4 would be, negative 10. You guys try. We're going to evaluate the function for the given input values. You're going to look for when t is 6 and when t is negative 2. Pause the video now. Okay, welcome back. So when t is 6, we're going to substitute g of 6 equals 1.5 times 6 minus 5. So g of 6 would equal 4. When t is negative 2, we find that g of negative 2 equals negative 8. In this lesson, you learn how to write an equation in function notation and evaluate a function for given input values.